Hello world! If you follow my videos, you should be familiar with Zeal 8-bit computer. On the left, we have the motherboard, based on a Z80, and on the right, the custom video board based on an FPGA. Let's see how to write a small graphical program for it. Before starting, I highly recommend you to watch my previous video about how graphic works on the 8-bit computer, as today we are going to put in practice what I talked about in that video. So the first thing to do is to create a tile set. To do so, I take this sheet which contains characters, and that other sheet which contains environment items such as palm trees, sand, water, and some bricks, and I'm going to make a custom tile set sheet out of them. Let's do this right now. Okay, here is the tile set sheet I came up with. We can find back the characters and all the most important elements. So now what we have to do is convert the colors to the VGA colors, VGA palette colors. So we can do this with GIMP by selecting mode and indexed, then we choose VGA from the VGA palette selection. And finally we can click convert. You will see that on the right there is the VGA palette that is showing. What we can do now is select any pixel on the picture and GIMP will show us which color it is in the VGA palette. You can see the number on the right, and this is very handy in some cases. Before exporting, we have to make sure that we have only one layer, so we are going to merge them, as I just did, and remove the alpha channel, because we don't want any transparency. Then we can click File, Export As, and in the Select File type, there is a very interesting extension, which is raw image data. This is what we are going to use now. Okay, let's check the content of the file thanks to xxd command, which will show the content in hexadecimal format. Here we can find back in hex all the colors values from the VGA palette, and so 1 byte represents 1 color, and so 1 pixel. So this is exactly what we want for Zeal 8-bit computer. Or almost. You see, the picture that we just exported has several tiles on the first line, so it means that the first 16 bytes belong to the first tile, but the second block of 16 bytes belong to the second tile. What our video card is expecting is that the first 256 bytes belong to one tile, and the next 256 bytes represent the second tile. So I wrote a small Python script which will convert any raw tileset into the tileset which is expected by Zeal video card. Using it is pretty simple. I only need to provide the input file, the number of tiles per line, and the output file. Once finished, it will provide me the total number of tiles and the image height. Now let's get the tilemap done. To do so, I will use a program called Tiled. It's very handy, very simple, and it's free. So let's open it. On the main page, we click on New Map, we select the size, and then we click on Save As. We have to select the file to save it as. Then we get this grid, which is 40 by 30 tiles big, which is the size of the real screen. On the bottom right, we click on New Tileset, and we will load the file that we exported with GIMP. So this is the PNG file that I exported with GIMP. It represents our tileset, still the same. Then we can select any tile from it on the bottom right. Then click on any cell on the grid, and it will place it. So now I'm going to try to make an interesting map, and we'll see what I get. Okay, so here is what I got. As you can see, I'm not a very good map designer, but it will be enough for the demo that I want to make. So Tiled has a feature to export a map as a JSON file, but I was unable to find it within my version. And it turned out I had to update my version. So this is what I did. And finally, I was able to get a JSON file out of it. Let's check it. So I'm using the command less in the terminal to show the file. And we can see that there is a field called data. This is the one that we need. Each number represents the index of a tile, but the problem is this tiles start from 1. So the first tile is 1, the second is 2, etc. But what we need is that they start from 0. So the first one should be index 0. And so this is why I came up with a Python script, still, which will convert all this data into binary, and also it will make them start from 0. The script is simple. We pass the input file, the output name, and it will generate a file. This is the file that we can finally use within our demo. Let's write this demo now. Okay, I'll open VS Code. I'm using VS Code to write this demo and do Z80 programming in general. We start by including the video macros file, which contains all the macros that we will need for the graphics mode. We set the origin at 4000. This is the memory address where we will execute the program. So we create the main routine. We don't really need to name it. We will switch to the graphic mode, to the 640 graphic mode. We can do this by writing a single byte on the IO bus. So this byte is represented by tile mode 64 and the address is IO video set mode. So at the moment we need to do this by hand, but in the future we'll have an abstraction for this. Then we need to map the tileset memory of the FPGA. To do so, same, we only need a single byte on the IO bus. In this case we need to output map tileset macro on the IO address IO map video memory. After this, the tileset memory will be mapped. So the FPGA board does not support the MMU yet, so the destination address is still 0. So the source address is demo tileset. This is the label where we will load the binary file that we created at first. And finally, we can launch the copy thanks to LDIR instruction. So we do exactly the same thing for a tilemap. First, we map the tilemap memory thanks to a single byte on the IO bus. Then we copy the loaded binary file to the destination address 0 with the instruction LDIR, and finally we just create an infinite loop. Now that the program is finished, we can compile it thanks to Z80ADK. I really like it because it has a very good assembler. Then we can retrieve the size of the binary and we can send it to the board. I will use UART for this. I will use this USB to TTL adapter. I plug it to the computer. I plug the UART pins on the board directly and also ground. Okay, the board is ready. I can finally power it up. And here comes the monitor. So I can use UART receive command to receive any program, and I need to specify the size of the program to receive. On the computer end, I simply use the cat command to send the program through the UART. I did program the adapter with the correct baud rate. Once we see the prompt again, it means that the program has been received completely. We can now execute it thanks to exec and the address where it has been saved, 4000. And here it is. We're almost there. There is just a small bug at the top of the screen. Let's see what is this bug. So now we've drawn the background layer. However, we have another buffer, which is called the text color attribute array. When we're in graphic mode, it's also used as a top layer for the tiles, so we have two layers. However, the monitor has already written colors attribute to this array, so now the colors are interpreted as tiles, and this is why we get this. This is our bug. So now we first need to reinitialize this array or reset this array directly inside our program before the infinite loop. Let's do this. Okay, now it's done. We simply need to compile back the program, retrieve its size, and repeat the process on the board to send it through UART. It's received. Let's execute it. And yeah, great. It works now. The result is as expected. Great! And everything is running on real hardware. So that's all for today's video. I hope you enjoyed it. And by the way, Zeal 8-bit Computer's website has been published. You will find more info about the project. You can check it at zeal8bit.com. I will put a link in the description. As usual, if you have any question or suggestion, you can leave a comment right below. See you next time.